Let's read the question. Diagram 11. One links 3 sets with arrows, one for the function f and one for the composite gf. We're also given part of the graph of g, and we work through 4 short tasks. Here's what we're given: the arrow diagram relating the 3 sets and part of the graph of g, which cuts the y-axis at 0, p. And here are the tasks. State gf, find the inverse of f and then g itself, sketch the inverse graph, and spot the pattern when f is applied over and over. So here is what we have and what we must find. From the diagram, f sends x to x minus 2, and there are 4 tasks to clear. Step 1. Part Adjust asks us to read the composite straight off the diagram. The function f carries x from set A across to set B, where it becomes x minus 2. Then g carries that value down into set C, where x lands on x squared plus 1. The arrow that runs straight from set A to set C is the composite gf. Do f first, then g, so read it off directly. Don't substitute f into g of x. Following the arrows, x ends up at x squared plus 1. So gf of x is x squared plus 1. That settles part A. Step 2. Find the inverse of f, which undoes what f does. Let y be f of x, which is x minus 2. To invert a function, we make the input the subject, then swap the names back. Rearrange to make x the subject. X is y plus 2. Swap the labels back, and f inverse of x is x plus 2. Now, use the inverse to pin down g itself. Let t be f of x, that's x minus 2. Then x is t plus 2, which is exactly f inverse of t. That's why we found the inverse first. A composite gf of x means g of f of x. Since f of x is our t, the left side is simply g of t, and we already know gf of x is x squared plus 1. Swap x for t plus 2 on the right. G of t is t plus 2, all squared, plus 1. Rename t back to x and expand. G of x is x squared plus 4x plus 5. Step 3. To sketch g inverse, first read the key features of g, then reflect them in the line y equals x. In vertex form, the lowest point is negative 2, 1, and the branch shown is increasing for x at least negative 2. Putting x equal to 0 gives g of 0 is 5, so p is 5. The point 0, 5 sits on g. Reflecting in y equals x swaps the coordinates, so 0, 5 on g becomes 5, 0 on g inverse. That's its x-intercept. Now the sketch. A graph and its inverse are mirror images in y equals x. Draw the axes. The dashed line y equals x is our mirror. This amber curve is g, the increasing branch, through its y-intercept 0, 5. Reflecting g in that line gives the mint curve, g inverse, crossing the x-axis at 5, 0, the mirror of 0, 5. Step 4. Here f squared means apply f twice, not square the answer. Let's iterate and watch what happens. Start from f of x is x minus 2. Feed x minus 2 back into f. That takes off another 2, giving x minus 4. Once more, an f cubed is x minus 6. And f to the fourth is x minus 8. Now spot the pattern and jump straight to f to the 75th. Each extra application of f subtracts another 2. So after n applications, f to the n of x is x minus 2n. Put n equal to 75. F to the 75th is x minus 150. Here are the final answers. Part A, gf of x is x squared plus 1. Part B1, f inverse is x plus 2 and g of x is x squared plus 4x plus 5. Part B2, g inverse is g reflected in y equals x passing through 5, 0. Part C, f squared is x minus 4, f cubed is x minus 6, f to the fourth is x minus 8, and the pattern gives f to the 75th as x minus 150.